A very good day. We are from Group 2, Subgroup 1 will be present a general reflection entitled Energy Recovery from Plastic Waste. Before that, did you know about pyrolysis of plastic waste? Pyrolysis of plastic waste is a process where plastic waste is converted into liquid fuel. There are many studies that have been conducted, however, none of these studies conducted according to the real value of plastic waste. The real plastic waste statistic can be referred to the data of non-recycled plastic that was provided by waste management authorities. The definition of NRP is plastic that was not redirected for recycling and it remained in municipal solid waste. There are many types of plastic such as PVC, PET, and PS. However, some of them cannot be recycled due to the different physical properties of plastic, which may clog the machineries during recycling. The worldwide plastic consumption has reached about 322 million tons in 2015, representing 4% increase over 2014. The increasing resulting a growing number of NRP for each year. Therefore, the objective of this study is to investigate the potential production of liquid fuel based on different consumption, and also to investigate the effect of polystyrene addition into feedstock for product improvement.
Now I will start with material and methods parts. The pyrolysis experiment was performed using an updrive stainless steel fixed bed reactor under atmospheric pressure with an internal diameter of 0.05 meter and total length of 1.27 meter, as can be seen in the figure here. This study was divided into two scenarios. The first scenario was arranged to obtain an overview of the potential liquid yield produced based on different composition of NRP in Malaysia, US, UK, and also global. The second scenario was aimed to improve the liquid quality by adding PS into the NRP composition.
Results and discussions. First, characterization of plastic materials. The table shows proximate analysis and ultimate analysis results. For the proximate analysis results, PET has a slightly higher moisture than others. Fixed carbon can only be found in PET and PVC. Lower amount of volatiles also in PET and PVC, and substantial amount of ash was observed in PET and PVC compared to the others. For ultimate analysis results, it can be seen that PET has high oxygen content, indicating that it had a lower calorific value. PVC has high chlorine content, therefore its product of pyrolysis is not suitable to be used as fuel. Next, the graph shows the TGA analysis of different types of plastics. It was concluded that 500 degrees Celsius is the most effective temperature for pyrolysis. PET and PVC was excluded from the materials as the pyrolysis of PET was inefficient and PVC produced hydrogen chloride, which could cause damage to the process equipment. Secondly, the pyrolysis yield. The table shows the product yields from pyrolysis of NRP from selected countries and globally. The sequence of the pyrolysis oil yield of the four thermoplastics in an ascending order would be from HDPE to PE to LDPE and PS. Malaysia was observed to produce higher liquid yield than US due to the high composition of LDPE and PS, which helped to boost the liquid product obtained from pyrolysis, even though we have the highest amount of HDPE in its waste stream. This indicates that these polymers did not react independently and there was an interaction occurred between the plastic samples. Next, the table shows the product yield from pyrolysis of NRP from Malaysia with addition of polystyrene. From the table, it was observed that the pyrolysis oil kept increasing with the increase of PS. Besides, the tar formation and non-condensable gases also reduced as the ratio of PS increased. In terms of the physical appearance, the liquid obtained from the pure NRP pyrolysis was mainly in wax form. However, with the increase in PS addition in this study, managed to reduce the waxy appearance of the liquid product. This indicates that a reactant containing high PS content was easily cracked to light liquid product. Third, the characterization of pyrolysis product. Firstly, the oil product. The table shows the oil properties of a pyrolysis of NRP. Water content and composition of oxygen was observed to be reduced as the ratio of PS addition into NRP increased. In addition, the HHV of the oil with 100% addition of PS almost reaching the HHV for diesel. This shows that the addition of PS into NRP pyrolysis managed to improve the physical and chemical properties of the pyrolysis oil to be comparable to the conventional diesel. Besides that, FTIR and GCMS analysis was also done on the pyrolysis oil. The FTIR spectra obtained implied the presence of alkane, alkene, and an aromatic group, which indicates the high aliphatic nature of the pyrolysis oil. GCMS analysis shows that the pyrolysis oil is abundant with aliphatic compounds, and it increased after 100% of PS additions. The overall results of GCMS analysis gives a clear indication that the pyrolysis oil has potential to be used as a combustible fuel source. Next, the gas products. The main gas produced during pyrolysis of NRP was methane. The graph shows the composition of methane gas from pyrolysis of NRP. It can be observed that the maximum production of methane gas from pyrolysis of NRP with addition of 100% PS is higher than the pure NRP. In addition, the reaction time was also reduced to 0 to 5 minutes. During pyrolysis, tar was also collected as residue in the reactor. The table shows the elemental analysis and HHV results of the tar byproducts. The HHV of the tar decreased as the ratio of added PS increased. However, the exhibited values are still superior than the HHV of standard coal, which usually obtained in the range of 36 to 41 megajoules per kilo, indicating that it had a high potential to be used as an alternative solid fuel. Fourthly, the discussion on PS addition scenario. Polystyrene has been observed to play an important role in increasing the liquid yield and improving qualities such as reducing water content in the oil, lowering the oxygen content, increasing the HHV, and reducing the waxy appearance in the production of liquid fuel derived from NRP.
Conclusion. First, pyrolysis technology can be used to convert non-recycled plastic to alternative energy source. Second, the liquid, gas, and tar produced from pyrolysis show high energy content. And lastly, the addition of polystyrene can increase the quality and quantity of the oil produced.
Moving on to the benefits of energy recovery from pyrolysis. So the first benefit is the technology is relatively simple with high product output. Almost all types of solid waste can be used in the system to generate power, and all of the power generating processes occur in a pyrolysis reactor such as this one, along with some accessory machineries. So the next benefit is it can return a high profit for the company. So plastic waste that comes from polyethylene, polystyrene, and other types of plastics have high oil yield, which can reach up to 50%. And a successful oil extraction from 10 tons of plastic waste can generate around 5 tons of pyrolysis oil fuel. The third one is to reduce the amount of plastic waste in landfills. As we know, plastic takes a very long time to decompose and they fill up landfills, so that is not a good thing. And instead of throwing that away, we can use them to generate power instead. Last but not least, it replaces non-renewable resources such as coal and petroleum, and it can act as viable energy generator. However, this process does not come without any limitations. It has some, and I have listed 3. The first one is it has the potential to release toxic air emissions to the environment, such as dioxins, acid gases, nitrogen oxides, and etc. The next one is it also has the potential to produce toxic residues such as inorganic compounds and inert mineral ashes with high heavy metal content, which is not good for the ground. Last but not least, it requires high investment and operational cost to maintain the reactor or plant.
Recommendation. PET and PVC are recommended to be removed from this pyrolysis technology. Second, the implementation of this project has given opportunity to develop new technique and detect oil source. And third, the other waste such as tires, rubber, and medical waste are also recommended to be used in pyrolysis technology for further studies.
Here is the list of references that we use in this journal reflection. Last but not least, thanks for watching.